Hi students, I am Dr. Satish Chavan, your chemistry teacher. Welcome you in the video lecture 6. In this video, we will learn molecular orbital energy level diagram for the formation of B2, C2 and N2 molecule. Let us begin our story with molecular orbital energy level diagram for B2 molecule. This molecule is formed by the combination of two boron atoms. Each boron atom has electronic configuration 1s2, 2s2, 2p1. The 1s orbital is lower in energy so that it does not take part in bonding. Thus 1s orbital remain as non-bonding orbital. Only 2s orbital and 6 2p orbitals of two boron atoms, that is total 8 orbitals, form total 8 molecular orbitals. Here 2s orbital and 2p orbital of boron atom are close in energy. Their energy gap between 2p and 2s orbital is less, so they interact with each other, and therefore the sequence of energy levels of molecular orbital can be given as sigma star sigma 2s sigma star 2s less than pi 2py is equal to pi 2pz less than sigma 2px less than pi star 2py is equal to pi star 2pz less than sigma star 2px. The remaining 6 electrons of the B2 molecular orbital are filled following above principle and Hund's rule of maximum multiplicity. The 2 electrons are filled into sigma 2s bonding molecular orbital, and the next 2 electrons are filled into the sigma star 2s anti-bonding molecular orbital. The remaining 2 electrons occupy the pi 2py and pi 2pz orbitals with parallel spins. These two molecular orbitals are degenerate molecular orbitals. The molecular orbital electronic configuration of B2 molecule is written as kk sigma 2s2 sigma star 2s2 pi 2py1 pi 2pz1. Let us consider the molecular orbital energy level diagram for B2 molecule. This is an energy axis. Consider the first boron atom having 2s and 2p atomic orbitals. Also we have the second boron atom having 2s and 2p atomic orbitals. The combination of 2s orbital of first boron and second boron give rise to the formation of molecular orbitals, that is sigma 2s bonding molecular orbital and sigma 2s antibonding molecular orbital. Similarly, 2py and 2pz orbitals of first boron atom combine with 2py and 2pz orbital of the second boron atom and give rise to the pi 2py pi 2pz bonding molecular orbitals and pi star 2py and pi star 2pz antibonding molecular orbitals. These are having the similar energies, therefore these molecular orbitals are degenerate molecular orbitals. The 2px orbital from boron 1 and 2px orbital of the boron 2 get combined to form sigma 2px molecular orbital bonding molecular orbital and sigma star 2px antibonding molecular orbital. There are energy gap between the 2s and 2p orbital is less, therefore 2s orbital of boron 1 and boron 2, they interact with each other. Let us consider that there are 2 electrons in the 2s orbital of boron 1 and 1 electron in 2p orbital. Similarly, we have 2 electrons in the boron 2 and 2s orbital and 1 electron in the boron 2p orbital. The two electrons are occupied in sigma 2s bonding molecular orbital and two electrons are occupied in sigma star 2s bonding molecular orbital. The one electron from 2p orbital of boron 1 is occupied in pi 2py orbital and other electron is occupied in pi 2pz molecular orbital. Thus, in boron atom there are 4 bonding electrons in the 4 bonding molecular orbitals and there are 2 electrons in the anti-bonding molecular orbital. Let us calculate the bond energy and bond order for the boron molecule. The stabilization energy of B2 molecule is found out by using formula energy evolved E is equal to number of electrons in the bonding molecular orbital into minus B plus number of electrons in anti-bonding molecular orbital into plus B. So that is equal to 4 into minus B plus 2 into plus B, that is equal to 2B. The bond order of this molecule is given by the formula bond order is equal to 1/2 number of electrons in the bonding molecular orbital minus number of electrons in the anti-bonding molecular orbital, that is equal to 1/2 into bracket 4 minus 2, that is equal to 1. This bond order is 1. The B2 molecule exists in vapor state. It has bond length 1.59 angstrom and bond energy 69 kilocalories per mole. Since 2 electrons are unpaired, the molecule is paramagnetic. Molecular orbital energy level diagram for C2 molecule. This molecule is formed by the combination of 2 carbon atoms. Each carbon atom has electronic configuration 1s2, 2s2, 2p2. The 1s orbital is low energy orbital, therefore does not take part in bonding, and thus 1s orbital remains as non-bonding molecular orbital. Only 2s orbital and 6 2p orbitals of 2 carbon atoms, that is total 8 orbitals, form total 8 molecular orbitals. Here 2s and 2p orbitals of C carbon atom are close in energy, so they interact with each other, and the sequence of energy levels of molecular orbital is sigma 2s less than sigma star 2s less than pi 2py is equal to pi 2pz less than sigma 2px less than pi star 2py is equal to pi star 2pz less than sigma star 2px. The remaining 8 electrons of the C2 are filled in molecular orbitals following above principle and Hund's rule of maximum multiplicity. First 2 electrons are filled in sigma 2s bonding molecular orbital and the next 2 electrons are filled in sigma star 2s antibonding molecular orbital. Remaining 4 electrons are occupied in pi 2py and pi 2pz orbital with antiparallel spins. These orbitals are degenerate molecular orbital. The molecular orbital electronic configuration of C2 molecule is written as kk sigma 2s2 sigma star 2s2 pi 2py2 and pi 2pz2. Let us see the molecular orbital energy level diagram for C2 molecule. This is an energy axis. This is the 2s and 2p orbitals of carbon 1. These are the 2s and 2p orbitals of the carbon 2. They give rise to the molecular orbitals sigma 2s, sigma star 2s, pi 2py, pi 2pz, pi star 2py, pi star 2pz, sigma 2px, sigma star 2px. There are two electrons in the 2s orbital, 2 electrons in the 2p orbital of carbon atom 1. Same is for the carbon atom number 2. The electrons occupy sigma star sigma 2s, sigma star 2s bonding molecular orbitals and anti-bonding molecular orbitals. The electrons are occupied in pi to py and pi to pz. So for carbon molecule we have 6 electrons in the bonding molecular orbitals and 2 electrons in the anti-bonding molecular orbitals. The stabilization energy of C2 molecule is found out by using the formula energy evolved is equal to 6 into minus b plus 2 into plus b, that is minus 4b. The bond order of C2 molecule is given by the formula 1 half 6 minus 2, that is equal to 2. The bond order is 2. C2 molecule exists in the vapor state. It has bond length 1.31 angstrom and bond energy 150 kilocalories per mole. Since 2 electrons are paired, the molecule is diamagnetic. Let us consider the molecular orbital energy level diagram for nitrogen molecule. Nitrogen molecule is formed by the combination of 2 nitrogen atoms. Each nitrogen atom has electronic configuration 1s2, 2s2, 2p3. 1s orbital is lower energy orbital, so that does not take part in bonding. Thus 1s orbital remain as non-bonding orbital. Only 2s orbital and 6 2p orbitals of 2 nitrogen atoms, that is total 8 orbitals, form total 8 molecular orbitals. Here 2s and 2p orbitals of nitrogen atom are close in energy, so they interact with each other, and the sequence of energy levels of molecular orbital is sigma 2s less than sigma star 2s less than pi 2py is equal to pi 2pz less than sigma 2px less than sigma star 2py is equal to pi star 2pz less than sigma star 2px. The remaining 10 electrons of nitrogen molecular orbital are filled following above principle and Hund's rule of maximum multiplicity. The first 2 electrons enter into the 2s bonding molecular orbitals. Next electrons are filled into the sigma star 2s bonding molecular orbitals, and the remaining 6 electrons occupy 2py, 2pz and sigma 2px molecular orbitals with antiparallel spins. These 2 molecular orbitals are degenerate molecular orbitals. The MO electronic configuration of N2 molecule is written as kk sigma 2s2, sigma star 2s2, pi 2py2, pi 2pz2, sigma 2px2. Let us consider the molecular orbital energy level diagram for N2 molecule. This is an energy axis. This is the 2s and 2p atomic orbitals of nitrogen 1. These are the 2s and 2p atomic orbitals of nitrogen 2. The combination of 2s orbitals gives rise to the molecular orbitals sigma 2s bonding molecular orbital, sigma star 2s anti-bonding molecular orbital. Similarly, 2py and 2pz combined with each other form pi 2py and pi 2pz bonding molecular orbitals, pi star 2py, pi star 2pz anti-bonding molecular orbitals. 2px orbital gives rise to the formation of sigma 2px and sigma star 2px anti-bonding molecular orbitals. Nitrogen contains 2 electrons in s orbital and 3 electrons in 2p orbital. Similar, we have 2 electrons in the 2s orbital of nitrogen 2 and 3 electrons in the 2p orbital of nitrogen 2. Sigma 2s occupy the 2 electrons with antiparallel spin. Sigma star occupies 2 electrons, pi 2py occupies 2 electrons, pi 2pz occupies 2 electrons, sigma 2px occupy 2 electrons. So in case of nitrogen, there are 8 electrons in the bonding molecular orbital and 2 electrons are present in the antibonding molecular orbital. The stabilization energy of nitrogen molecule is found out by using the formula energy evolved is equal to 8 minus beta plus 2 into plus beta. Therefore, energy is 6 beta. The bond order of this molecule is given by the formula 1 half 8 minus 2, that is equal to 3. The bond order is 3. Nitrogen molecule exists in triple bond state. It has bond length 1.10 angstrom and bond energy 226 kilocalories per mole. Since all the electrons are paired, the molecule is diamagnetic. Dear students, we have seen in this video molecular orbital energy level diagrams for formation of B2, C2 and N2 molecule. In the next part, we will consider the molecular orbital energy level diagrams for O2 molecule. Thank you.